Now, I've given you guys these little graphs before, and we're going to see what happens here. So if I start off and I have position time, we talked earlier, what's the slope? Well, the slope we talked about meant speed. Now after that, then we said, okay, if we get that one, let's take a look after at a speed time graph, right? That's what we're doing kind of now in this problem. And then we take a look at the slope, and we found out that the slope was average acceleration. Then we took it a step further just now, because we graphed this out, and we took a look at an acceleration time graph. And what we found was this kind of linear line. Now, there was another part to this as well, in that we started to take a look under the curve, or under the line. So if I take a look under this line and look at this space right here, this space, if anybody remembers maybe, works out to be our displacement, right? It goes back to distance. So the way that this works out, especially for this one because it makes that triangle shape, right? Area is equal to half base times height. And so if you take a look at area here, it's 1/2 the base of this thing, and the base in this case is time, it's measured in seconds, and the height is measured in meters per second. So ignoring numbers, just look at the units. The seconds units cancel, and I'm left in meters. So the area of a velocity time graph gives me a distance unit. That distance unit can go back to there. But that means that they must be connected. So I can do the same thing for an acceleration time graph and take a look under here. What do you suppose the equation would be to look under that one? Well, it's a rectangle, so area just equals length times width. And then if I look at the units here, area is equal to meters per second squared and seconds. Well, what happens here? I have seconds on the top. Remember, this is like a fraction. And seconds squared on the bottom. They're going to cancel out one of the second squared units, and I'm going to be left with meters per second. So this actually gets me back to there. Gets me back to my velocity time. So the slope of a line moves forward and becomes the y-axis of the next one. And the area of the curve actually works backwards and gives me the y-axis going back. It's one big loop, one big cycle. So let's see how that applies to this example that we just worked out. If I take a look at the acceleration time graph, let's say I wanted to know what the area is at 4 seconds. Okay, what's this total area right here? So you can see pretty quick, it's 2 times 4, right? So area is length times width, which means area is equal to 2.0 meters per second squared multiplied by 4.0 seconds. Area is equal to, the seconds unit cancel, right? One with one of them gives us 8 meters per second. That means at 4 seconds, I should be at 8 meters per second. And sure enough, if I go back and I look at our graph from before, look at this. At 4 seconds, I'm at 8 meters per second. So let's try out another one. What if I didn't want to do the full 4 seconds? What if you wanted to go shorter? Right? What if we just wanted to take a look and do this at 2 seconds? So if I just wanted to say, okay, what's the area here at 2 seconds? Then the area at 2 seconds would just be 2 times 2. So I'd have 2 meters per second squared and multiply that by the 2 seconds. The same thing happens, the second units cancel, but this time I'm only getting 4 meters per second. So at 2 seconds, I should be up to 4 meters per second for a speed. And if I go back and I look, at 2 seconds, I'm up to 4 meters per second for a speed. So I could go back and we could look at any time interval and it would match up to what we have here just by looking at the area under the curve of an acceleration time graph. But we know that also goes a step farther. I should be able to take a look at the area under a velocity time graph and get the same kind of information. So if we took a look here at this velocity time graph, and I wanted to find the area of the space under this slope. So let's say I wanted the full 4 seconds, okay, all the way right there. This shape isn't a rectangle anymore, triangle shape, and so we know that area is equal to 1/2 the base times the height. So what is 1/2 the base times the height in this case? Well, the area of this one is 1/2 times the base, which is 4 seconds, times the height, which is 8 meters per second. So the seconds units cancel, top and bottom, and I'm left just in meters. And so it's 8 times 4, 32, divided by 2 is 16.0 meters. That means at 4 seconds, this thing has traveled 16 meters. And I should be able to verify that if I go way back to the beginning and I take a look at 4 seconds, this thing has traveled 16 meters. So we can go and we can take a look at any of those and verify our calculations by going through and looking at the graphs. So if we do one more, just to kind of show another example, if I do the same thing again, but let's say this time I didn't want to do the 4 seconds, let's say I wanted to do 2 seconds and just see where this ended up. So at 2 seconds, now I've got a much smaller triangle. I'm still going to run through the same thing. Area is equal to 1/2 the base times the height. So area is equal to 1/2 the base, which is this time is our 2 seconds, times the height, which this case is 4 meters per second. 4 meters per second. The seconds units are going to cancel again. Bottom and top, it leaves me with meters. And so it's 4 times 2 is 8, divided by 2 is 4. So this gives me 8 meters. If I go back and I take a look at our graph, for position time at 2 seconds, I should be at 8 meters. Oh, did I say something wrong? Oh, 4 times 2, sorry, my mistake. 4 times 2 is 8, half of that is 4. I did make a mistake there. So half of that is 4. And so if I go back here and I take a look at 2 seconds, I'm at 4 meters. So we can take a look at any point, any time interval, and we can find what the positions are. And it's all connected from this whole idea of seeing that distance time can connect to speed time, can connect to acceleration time graphs. That's definitely a cue card kind of thing. So I do have a couple of problems for you guys to try, and good luck.